Hello students, in my last lecture I had discussed refraction of light through rectangular glass slab. Today we shall see laws of refraction and refractive index. So first of all, see what are laws of refraction of light. First law states that suppose this is a boundary between two transparent media, and at any point this is incident ray, this is normal at the point of incidence, and there may be two situations: either rays of light travel from rarer to denser or to denser to rarer. So with the property of rectilinear propagation of light should travel on a straight path, but due to refraction of light we have seen that rays of light change their path. So what happens? If rays of light travel from rarer to denser, then they bend towards the normal. See, bend towards the normal. Now we can easily explain laws. First law states that the incident ray, the refracted ray and the normal at the point of incidence all lie in the same plane. Once again, learn what is the meaning of incident ray. Here, this ray is incident ray. We should really learn top materials. Suppose this is point O. So this point is point of incidence. Point of incidence. Suppose this is OO dash. So OO dash is normal at the point of incidence, and this ray here, suppose this is AO. So AO is incident ray and OB is refracted ray. This ray is refracted ray. So this is refracted ray. Refracted ray. We have seen already the angle between incident ray and normal. This angle is called angle of incidence, and the angle between refracted ray and normal, this is normal here, this is called angle of refraction. So practically we must know what are the actual position of different physical terms mentioned here. Now what is second law? Second law states that the ratio of sine of angle of incidence to the angle of refraction is a constant for a light of given color and for given pair of media. It is very important because maximum students write laws of refraction just like as laws of reflection, but laws of refraction are quite different from laws of reflection. First law has some similarity because in the first law of reflection we had seen what? The incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. But here we see the incident ray, the refracted ray. The word is refracted and the normal at the point of incidence all lie in the same plane. And second law of reflection was what? Second law of reflection was the angle of incidence is equal to angle of reflection. But here the second law is quite different. Second law of refraction is that the ratio of sine of angle of incidence, that is sine I divided by sine of angle of refraction is equal to constant for given color of light and for given pair of media. Suppose this medium is air, this medium is water. For these two media, the value of constant will be something other. But if we take first medium as glass and second as water, then this constant will be now something different. So it depends on the nature of color of the light and for given pair of media. This second law of refraction, this law, that is second law of refraction, is also called the Snell's law. Snell's law. It is very important and interesting question. Sometimes there will be a question, what do you mean by Snell's law? Write Snell's law. So second law of refraction is also called Snell's law. Now, one thing is very important here. This constant value, here we say that ratio of sine of angle of incidence to sine of angle of refraction is equal to constant. But this constant value is called the refractive index of the second medium with respect to the first. So write down it clearly. This constant value, very important thing, is called the refractive index of the second medium with respect to the first. With respect to the first. So it is very important on the point of view of your knowledge, and also it is very important for examination. So really learn it and try to write it 2 or 3 times. Now I have used here refractive index. So what is the meaning of refractive index? Just know what is refractive index. We have seen in our previous classes. I'm just giving you a refraction of refractive, just some description of refractive index. In our previous classes, what we have seen? We have seen the speed of light is represented by c, and it is 3 into 10 to the power 8 meter per second. But where this value is in vacuum, this value of a speed of light is in vacuum. This speed is not constant everywhere. And I have also seen that if rays of light travel from one transparent medium to another, then due to the change in optical density, always I am using the term optical density here. Optical density. Optical, the word optical comes from optics. The study of light is also called optics. So optical density, we have seen rarer medium and denser medium. If any medium is rarer, it indicates that the optical density of that medium is less. And if any medium is denser, it indicates that the optical density of that medium is more. So due to change in optical density, a speed of light also changes. Higher is the optical density, lower is the speed of light. Lower is the optical density, higher is the speed of light. So if rays of light travel from one transparent medium to another, then the ratio of a speed of light in given pair of media is called refractive index. We shall learn it in detail in our next lecture. So I am concluding my lesson today, and homework for you is that learn and write the laws of refraction of light. Dear students, one thing is very important. This is my lecture number 11. But when I started telephonic contact with different parents and students, and I collect the output, then maximum of you have visited only 4 to 5 lectures. So I have stated many times. Once again, I am giving you suggestion that you people, that is students, are a real hero of teaching learning process. During this long time period, it is very difficult for us to start our regular classes. So consider this is your regular class. Daily we are providing you 5 to 6 lessons. So daily try to learn it. You have sufficient time, you have maximum time, so don't waste your time, and if you take interest, then our effort will be really fruitful. Now I hope that you all will take active participation in this teaching learning process. Thank you very much.